Today we're going to cover P5, Section C, or Day 3 of this. And today we are going to add and subtract rational expressions. So again, rational expressions, all that means is we're adding fractions. So if you remember back to 4th grade when you learned how to add and subtract fractions, remember fractions must have the same denominator in order to add them. Just like we did with the multiplication and division, you must factor everything first, or at least factor the denominator. Then you're going to find the least common denominator, the LCD, of each term for the expression to the highest degree. And we're going to see what this means in a minute. Remember, whenever you're finding a least common denominator, you're multiplying each term by what's missing from the denominator. Once you have the LCD, then you're just going to add and subtract the numerators only. And then you'll just use that LCD as your denominator. Now, let me show you what I mean by we always multiply to find the LCD. So, for example, back to 4th grade math. Let's say I ask you to add 1/2 plus 1/3. Remember, what we're doing here is trying to find the least common multiple between 2 and 3, and that least common multiple is going to be 6. So now, what I need to do to get that denominator of 2 to turn into a 6, remember you're going to multiply to make it become a 6. Whatever you do to the denominator, you have to do to the numerator. So then this would turn into 3/6. And then for the 1/3, to make it have a common denominator of 6, times both the numerator and the denominator by 2. And now we just add the numerators. We're doing the same basic idea that we just did, but instead now our fractions, our rational expressions, are going to have polynomials. Now, common mistake. Again, I can't stress this enough, that when you're finding the LCD, we're multiplying. So for example, just to show you in basic terms, the common mistake is people are going to think, oh, my common denominator is 6. I could just add 4 here and add 3 here to get my common denominator. It doesn't work that way. It's always multiply to make it have the least common denominator. Does that make sense? And you're going to see that when what I'm talking about with variables. So these are the steps. Again, have to have a common denominator, factor first, and then from there, we're going to see what's missing. Let's try it. Oh, here's the same one I just did. Okay, so my common denominator here is 6. So we can see that it was missing, or it needed to be multiplied by 3 for this one. And this one needs to be multiplied by 2. And then you just add the numerators only, and you get 5/6. Now, maybe to see this a little bit better, so the next one, number 2, same thing. Sometimes the LCD is already there, and you just have to change one of the fractions. So for example, the 1/6, I need to change that because my LCD here is 12. So the second one stays, but the first one I'm going to times the numerator and the denominator by 2. And then I can add 2 plus 1, keep the same bottom, and this becomes 3/12, and then we simplify. Now we're going to get really into this. So now, always remember, common denominator. This one's already got it, so all I have to do is add my numerators. And this becomes 1 plus 2 is 3 over x plus 1. Nothing simplifies. This x plus 1 is attached. The next one, we're subtracting. It already has a common denominator, but be very careful. Okay, we're subtracting this whole numerator, not just the 2x. So what I like to do is think of this as a keep flip change. So really what's happening here is it's x plus 1 minus 2x minus 3. Now, and then it's got the same denominator. So you can either think, I just need to distribute the negative sign to both, and then I just combine my like terms. So minus 2x plus 3. I'm going to combine my like terms in the numerator. X minus 2x gives me negative x, and then 1 plus 3 gives me 4. And then it has the same denominator, the x plus 2. Again, remember, these are attached. Do not try to cancel the x's, and do not try to simplify 4 divided by 2. The only way something's going to simplify here is if it looks identical. I would need either another x plus 2 in the top to cancel it, or a negative x plus 4 in the bottom. Okay, so nothing simplifies here. You're done. Pretty good? Okay, let's try number 5. So again, I'm looking for a common denominator. This is being multiplied. So I just have to figure out what is this one missing, and this one's missing the times by 6. So let me go ahead and just rewrite the problem. So 1 over x plus 5 over 6x. So this one's missing, multiply by 6. Whatever you multiply to the denominator, multiply to the numerator. So this new fraction now becomes 6 over 6x plus, and this one stayed the same. Now I just add my numerator. 6 plus 5 is 11 over the common denominator. Now, here's where people mess up on number 6. Now notice this was multiplication. So I actually multiplied to find my LCD. However, this one, what most students try to do here, and this is wrong, they try to say, oh, this one just needs a plus 1, and this one gets a plus 1. We do not add to make a common denominator. We are multiplying. So this common denominator is actually going to be both of these. So my common denominator here is going to be x times x plus 1. Now, the first fraction is missing the x plus 1. So whatever you're going to multiply to get to the denominator, also do that to the numerator. So 1 times x plus 1 is just x plus 1. This one's missing just the single x. And again, just put the x on top. Now I'm going to add my like terms. So if it's better for you to see x plus 1 plus x over the common denominator, you can do that. And then I just can combine my like terms here, which are going to be 1x plus 1x is 2x over the common denominator. You do not need to FOIL it or distribute it. Leave it like that. Nothing cancels here. Remember, this 2x plus 1 is attached. Number 7. Again, we're not adding or subtracting to make a common denominator. We're always multiplying. And if you have two separate binomials here, then that denominator is going to be both of them. So my common denominator here is going to be x plus 2 times x minus 4. And now we need to multiply what's missing from each one. So my first fraction is missing the x minus 4. That's what I'm multiplying to the denominator. So I also have to multiply it to the numerator. 1 times anything is just itself. And the second fraction is missing the x plus 2. Now this one, I can go ahead and just leave it side by side. I'm going to distribute it because I got to combine like terms. Now, when we are adding and subtracting, you do need to distribute to the top. So I could go ahead and first just show you that this is what it is. But now what we need to do is either do a key flip change, or what I could do is say this, and now I'm going to distribute a -3. So it becomes x minus 4 minus 3x minus 6. I'm going to leave the bottom, the denominator, in factored form. Now I have to add my like terms. So this is why for the numerator you have to distribute, because we need to find like terms here. So I actually have an x and a -3x. So when I combine that, I get -2x. And then I can combine my constants. -4 minus 6 gives me -10. And then it's over the same denominator. Now, I could try to factor out a GCF of -2, but that's not going to do any good for me. But you should always attempt it. So I would be okay with you leaving it like this. However, once I pulled out a GCF, if this would have turned out to be something that would have simplified in the denominator, then you should do that. So always test it to see, because like if this, after I divided, was an x plus 2, then I would have been required to have simplified it further. But in this case, I would accept either answer here. But it's probably always a good idea to make sure and to factor it. Let's try the next one. Notice again, two binomials, nothing in common here. So my GCF is going to be both, not my GCF, my LCD. So x minus 3 times 3x plus 4. It's going to be in the denominator for both. And now we have to see what's missing from each. So my first fraction is missing the 3x plus 4. So in the top here, we're going to have x times 3x plus 4, and we're going to distribute it in a minute. The second fraction is missing the x minus 3. So 2 times x minus 3. Now, I have to distribute the numerator. The denominator I'm leaving. So for the numerator, it's going to become 3x squared plus 4x. And now, again, think of this as a -2 that you're going to distribute. -2x plus 6. X minus 3, 3x plus 4. Now I need to combine like terms in the numerator. So I can add or subtract 4x minus 2x. So now this becomes 3x squared plus 2x plus 6 over x minus 3, 3x plus 4. Now let's see if this numerator can factor. So we should always try to factor this. So 3 times 6, 18. Factors at 18, that could give me 2. That would be 1 and 18, 2 and 9, 3 and 6. None of them will give me 2, so that can't be factored. So I'm done, and I just leave it like that. So always try to factor whatever you simplify the numerator to, and see if it'll be something you can cancel with the denominator. Let's try 3 more examples and then we're done. So for number 7, number 9, same idea here. I got 2 binomials in my denominator. So that's what's going to be my common denominator. So I'm going to have 2x minus 1 times x plus 2, and then 2x minus 1, and then x plus 2. So the first fraction is missing the x plus 2. So whatever you're going to multiply to get as a LCD, you also have to do to the numerator. So this becomes x times x plus 2. And then the second one is missing the 2x minus 1. So then 1 times anything is just itself. Now be careful here because again, remember this is subtracting. So this subtraction sign needs to distribute to both terms. So let's go ahead and distribute the top of the first one. So that'll become x squared plus 2x, and then I distribute the subtraction sign. And then it's over the same denominator, 2x minus 1, x plus 2. I'm going to add my like terms. So I can do 2x minus 2x, and that's going to cancel out. So then now I'm just left with x squared plus 1 over 2x minus 1 and x plus 2. Notice the top is the sum of two squares. That cannot be factored, so I'm done. I don't even need to look for anything to simplify. Now, sometimes your denominator needs to be factored. So let's go ahead and factor that denominator, because in that difference of two squares here is one of the factors hiding. So this will factor into x minus 3, x plus 3. So let me go ahead and do that first. X plus 3, x minus 3, and then 4 over x plus 3. Now the reason why I factored it is if I don't factor it, then I'm going to end up with this monster problem that I'm going to have to simplify in the end. So notice what was hiding in here was already an x plus 3. So my least common denominator is actually going to be the x squared minus 9. But I'm going to go ahead and write it as x plus 3, x minus 3. So the first fraction is good. It has everything it needs. The only thing that I need to multiply to the second one is the x minus 3. And I'm going to distribute. And it becomes 4. Well, let me just write it like this first. Now I'm going to distribute. And it becomes 4x minus 12 over x plus 3, x minus 3. Now I can combine my like terms. I have a 2 minus 12, and this gives me negative 10 plus 4x. And then I have the denominator, x plus 3, x minus 3. And again, what I can do here is I could just flip it around as well. Let me pull a GCF out to see if anything cancels. I'm going to rewrite it first as 4x minus 10 plus 3 minus 3. And then here I could try to factor out a 2. And then I'm left with 2x minus 5. But notice it doesn't do anything for me to cancel. So because nothing simplifies, you could have left it like this, this, or this. But again, always test it to see if something after you factor it is something that'll cancel. Let's try the last one. Number 11. Now again, I'm going to factor this. Let me just do it right below it. If it factors into x plus 1, x minus 1. So that's my least common denominator. Notice this one has part of it and this has part of it. So let me write it down 3 times. So x plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1, and then now I'll add in my plus signs. So my first fraction is missing the x minus 1. So I'm going to multiply that to the top and the bottom. The second fraction is missing the x plus 1. So that becomes 2 times x plus 1. And then the last fraction was good. I just leave the 1 there. Now what I need to do is distribute the red, distribute the purple, and then combine my like terms. So the red becomes 2x minus 2. The purple becomes 2x plus 2. And then the plus 1. And this all has the common denominator of x plus 1, x minus 1. Now I need to look for like terms. So I have a 2x plus 2x. This gives me 4x. And then I have a negative 2 plus 2 is 0, plus 1 is 1. And then it's over my x plus 1, x minus 1. Now be aware that if I'm okay with you leaving it like that, but maybe on an SAT, they might FOIL it back and show it as x squared minus 1. But I prefer you just leave it like that in your factored form. Let's try one more because we got time here. Let me try a little bit more complicated one just to give you a little practice. Let me add one more example. So let's do 6 minus x over x times x plus 2 plus x plus 2 over x squared plus 8 over x squared times x plus 2. It's a little complicated here. So my LCD is going to be x squared and then the x plus 2. So I'm going to write that a bunch of times. So x squared times x plus 2, x squared times x plus 2, x squared times x plus 2. So my first fraction is missing just an x. So I'm going to times top and bottom by x. So x times 6 minus x. The second fraction is missing the x plus 2. So x plus 2, x plus 2. And then the last fraction has everything it needs. So I'm just going to leave the 8. Now, the pink and the red need to be distributed and FOILed. So the red is going to become 6x minus x squared. The pink, I'm FOILing that, and that's going to become x squared plus 4x plus 4. And then I have my plus 8. It all has the same denominator now. And now I'm going to combine my like terms. So I have, notice my x squared, negative x squared, plus x squared, and that's gone. Then I'm going to go back and grab my x's. 6x plus 4x is 10x. And then lastly, 4 plus 8 gives me 12. And then I have the same denominator, x squared, x plus 2. If I try to factor out a GCF out of the numerator, I get 5x plus 6. It doesn't do me any good, so I would accept either answer here. And that is it for the adding and subtracting of rational expressions.